All right, so what we have now is we have a character, he's running in place, and in endless runners, believe it or not, your character is not running across the surface. It just the objects look like they're moving, and that's because they're procedurally generated. So let's take a look at the process of procedurally generating a ground piece across the front as our character runs. All right, so let's right click here and let's create an empty game object and we'll just call this ground. All right, something else I'm going to do is I'm pretty happy with this light for now, so I'm just going to uncheck visibility there so we hide it. And if you ever need to, this stays on if you forget that it's off, and you want to get your access your light for any changes. All right, so here's our ground here. I'm going to go ahead and reset its position by clicking on these three little dots here and hitting reset because we always want to start it off at that world. And in case we have any section that needs anything else, we're just for now going to create a empty underneath it called model. And then I'm going to make a game object here. Actually, we could just right click here and then go 3D object, cube. And then what I'd like to do is I'm going to position this cube right underneath his feet. And then for the X, I'm going to make that 10 units wide. And this just makes the math a little bit easier, and 10 units this way. And now when we need to instantiate it, if we look here, we're at 0, 0, 0. And this is at 0, 0, 0 for scale. And then this is at 10, 10, 10. Or 10 and 10. And then I think we could probably just do minus 0.5, and that'll be right at his feet. Yeah. All right, so what I want to do next is in my prefabs folder here where I have my runner, is I'm just going to grab this same ground piece. I'm going to drop it into that prefabs folder. And then I can remove it from the scene. And what I can do is let's go ahead and write some basic code that'll instantiate that prefab in our scene. So in our new runner folder, let's create another folder here, and let's call this scripts. All right, and then in this scripts folder, I'm going to right click, I'm going to create a C# script. I'm going to call this level generator. Now, Unity 6 just came out recently, and we're going to finish this project in Unity 2022. If you're using Unity 6 and you're watching this, you want to right click and then click on use Unity Model Behavior Script. I'll probably have a video that talks about how to use Pro Builder with Unity 6 as well as just kind of the newer differences, but there isn't much. You can also convert this project, which I'll probably do later after this particular class is done, and convert this whole project to Unity 6 and just kind of work from there. All right, so let's do a couple things here. Let's create an empty game object in our scene. And let's see, let's name this, I don't know, level generator. It's called level gen. And I'll grab my level generator script, drop it on there. I'm going to kind of collapse this R folder so I can get to this easier. And what we'll do first is we'll create a serialized field. And we're going to make this a game object. And we'll just call this ground prefab. Let's jump back in here. And let's grab our ground and drop it in here. And then on start, we're going to instantiate the ground prefab at the current position. Transform position. This shouldn't be anything new to you. And I'll just put this on another line so we could see this. And then we do quaternion identity for the rotation. Now if I Control S and I save this and I press play, let's make sure level generation is reset to 0, 0, 0. Now when I press play, we get an error because I am missing a semicolon at the end of this line of code. So let's hit Control S, and I saw that because it's expected semicolon down here. And I'm going to actually close out this animator to give myself some room. So now when I press play, you can see it automatically instantiated that ground here. All right, let's go ahead and create a for loop. And what this for loop is going to do is instantiate a bunch of these different ground planes here. And let's see. When I typed 4 and I hit tab, it auto-generated this for me. And we've talked about for loops in the past, but just to be clear, the way the for loop works is you have a initial count value, so I equals 0, and then you have a test value. As long as I is less than something, we increment I. And then when I hits the, say it's 5 and then the value here is 6, we stop doing it. So for example, like let's say we put the number 6 in here and I hit Alt and I move this inside of here. I'm going to hit Control Alt Enter to tab that in and Control S to save. As long as I is equal to 0, and as long as I is less than 6, which means 5, we'll increment I. Watch what happens in my scene now when I press play. I have 1, 2, 3, 4, 5, 6 ground planes, right? Because I started at 0, and 0 actually counted as an object. So here's 1, 2, 3, 4, 5, and 6. And we instantiated it 6 times. I'm going to uncheck play. So I'm going to hit Control D here, and I'm going to change game object to int. And I'm going to change this to starting ground amount. I'm going to make that equal to 12. And I'm going to grab this, and I'm going to change it from 6 to starting ground amount. I'm going to hit Control S to save. I'm going to press play so you can see that we get roughly 12. And you can see we have 2, 2, 2, 2, 2, 2, 2. All right, we're getting there, guys. And then if you see, like, you're like, well, I don't want 12. Well, that's why I made it a serialized field, so you can make it whatever value you want. Now, what I want to do is, just like there is one of these ground planes, I want to give each time I spawn one of these ground planes, I want to make it a child of a parent object. And you'll see why in a second. So for now, just name this ground parent. And inside of our code, let's go ahead and write the code that will connect each time one of these spawns to one of these ground parent objects. All right, so I'm going to hit enter here. Actually, let's hit enter in front of this quaternion identity. Rider adds this quaternion rotation to kind of explain what this does. You don't have to do that. So what I'm going to do is I'm going to copy this ground parent name here, so I don't have to rewrite it because I'm a lazy programmer. I'm going to hit Control D here, and I'm going to change this to ground parent, and I'm going to make this of type transform, because what I want to get is the transform of this object, because that's what I'm going to be, and let's reset this over here. That's what I'm going to be parenting it to, and it's giving me an error on 12 because you can't put a numerical value in a game object transform. And there's a trick here that many people don't know about, is if you just put a comma here at the end of the instantiation and you write the name of the object that you want to parent to, it'll automatically say, hey, I want to instantiate this ground prefab at the current position, and not of this necessarily this object, but of this ground parent here, or the whatever the object is. So if we select this level generator and I grab my ground parent and I put it in here and I press play now, you can see as I expand this, now we have all of those pieces as a child, or like of my holder here of ground parent, which is kind of cool because, you know, we're kind of cleaning up our scene. I'm going to make sure to hit Control S here, go to Unity version control and check this in. All right, so I took the easy way out and I made it 10, and there's a reason for that. So let's go ahead and make a float value here and call this ground length, and I'm going to make that equal to 10f. And what we're going to use that is we're going to use that inside of our for loop to shift the position or the transform of each of these positions by 10 so that they move forward by 10. And we can do this as well. We can make this a serialized field in case you want to tweak it. So this code is going to be pretty interesting. It's going to take a little bit of logic, right? So let's talk about this. We want to get the current position on the z-axis. And what that is that current position is 0, right? Because we want to move it on our z-axis forward. So we'll make a temporary variable called spawn position. And we'll do z here. And what we're going to do is we're going to check if we are at the starting position of 0. And how can we check that? Well, an easy way to do that is to know that I is equal to 0. And that means we're starting our first spawning position here. So what I can do is I'm going to type if and hit tab so it auto-populates it for me. And if I say I is the same as 0 here, spawn position z equals transform dot position dot z So what that means is this spawn position here, which is this float value, which is equal to 0, is equal to that initial, is equal to whatever our z value is, right? And this is going to change because as things shift, this is going to update. Else, hit tab to write that out, spawn position z, and this is going to just update it, equals the current transform dot position dot z plus, and then we're going to do a little bit of basic multiplication here, I, and if I equals 0 at first, remember I goes 1, 2, 3, 4, it gets incremented, and we multiply it, I times the ground length. So what is the ground length here? Well, our ground length is 10. So I times 10, 0 times 10 is 0. So that's our current spawn position. 1 times, and if our spawn position is 1, our transform.position.z here equals 1 times ground length, which is 10. So that shifts us up to 10. And what I'm going to do here is I'm going to create a new vector 3 position, or vector 3 here, that we're going to use to store the ground spawn position. Just to go low position like that. And that equals a new vector 3 object. And what are the values we're going to pass in, right? Well, we're going to pass in, I'm just going to copy transform.position here, dot. The vector 3 has 3 values. It has an x, y, and a z. Well, the x and y value we know are just going to be 0. So we're just going to do this, dot x, so whatever that current position is, comma. And then we'll just do dot y. And then for the z, well, we've got all this calculation going on. We know it's spawn position z. We just put this in here. So let me go ahead and put this on a new line so we could see that a little bit easier in our code so I could zoom in. So when you're copying, let's make sure that we don't forget our semicolon here. And what this is going to do is as we instantiate it, this basic math where we're just multiplying it, let's get this in here, this will automatically increment it. So go ahead and like really run through that code one more time on your own. If I is the same as 0, it is. We're going to set the spawn position to 0, which is this position here, transform.position 0. Spawn position 0 equals transform.position.z plus I times this. And I want to show you something. So if I bring in this ground, for example, and here's the z-axis, right? If I take this position and I type in a 10 here, notice it shifts up. So let me hit Control D here. So remember, this is what's happening here. 1 times 10, because our ground length is equal to 10. So I'm going to hit Control D to duplicate this ground to really illustrate this. So I'm going to type 10 here. Oops, that's rotation. Notice how it goes right, it lines up right on that edge. So that's really all we're doing here. So if we save this and we press play, you can see we've just created a procedurally generated ground based on 10. And if you're not a really big math person and you're still struggling with that, just run through it one more time. I promise you it's pretty easy. It's just multiplying 10 along the z-axis. And I think that's it for now, and I'll see you in the next lesson.